Okay, we are live. Hello, everyone. Welcome to our second talk in the Learn Generative AI series. So the way this is going to work, we're going to wait a few minutes for people to kind of, trickle in and get settled. And after the first 2 minutes, we will start with our talk. But for the first 2 minutes here, we're just going to wait around for a little bit. For the first minute, if you can see me, if you are already here and you can hear me and you can see me, I would love to know where you are calling in from. Yeah, with that, we'll wait for another minute or so. And if anyone posts where they're coming from, I'll give you a shout out. Oh, cool. So we've got some people here. Someone's coming in from New York City. Oh, Varun's calling in from Seattle. I'm also in Seattle, so that's great. Someone's calling in from California, somewhere in California, I guess. It's a big state. Okay, so we are reaching our 2-minute mark. So I'm going to, Oakland in California. Bay Area. Oh, Crom's joining us from LinkedIn. I didn't even know I'd posted this onto LinkedIn. That's great. Okay, so we're hitting our 2-minute mark. I'm going to get started with the intro. I'm going to talk about what we're learning about today. And then once I'm done with the intro, I will bring Oscar to the stage. So first and foremost, today's talk is part of our Learn Generative AI series. This is part of the OSS for AI / Cracking Gen AI ecosystem. And so today we're going to be talking about evaluation and monitoring for LLM systems. The goal of our OSS for AI community is to bring this developer education to people around the world. We want to give developers the opportunity to understand, to use, and to develop and contribute to the direction of AI in general. And so these online series are part of our way that we reach people beyond our typical live in-person audiences that we do events for in SF, San Francisco, and New York, as many of you are. SF, Seattle, and New York, as many of you are calling in from. And so today's talk will be about evaluation and monitoring. And LLM, our talk abstract is that LLMs started as tools that we called, and now we use them as agents that decide for our users, for our engineering, and for the industry. As LLM systems gain autonomy, two concerns that used to be separate, evaluation and monitoring, converge into a single continuous loop. Drawing from production experience building AI-powered healthcare systems, this talk presents a practical framework for evaluating and monitoring LLM systems at every stage of autonomy. We'll cover how to define what failure actually means for your users, how to build a root cause taxonomy that tells you exactly where to invest, and how to turn a manual investigation into a self-improving monitoring pipeline. And we'll also explore what changes when the AI becomes more autonomous, how agents evaluate agents, step-level quality signals, and the emerging pattern of self-healing systems. So without further ado, I'll bring our speaker to the stage. Today, we're joined by Oscar Corbett. Oscar, welcome. If you could please share your screen, I will replace yours with mine, and then I'll take myself off the stage.
Yeah, perfect. Hi, everyone. There we go. I hope you can see my screen. Let me know.
Okay, there we go.
That works? Perfect.
That works.
Well, so I'm going to jump right into the subject. 9 seconds, that's how long it took for an AI agent with cursor running with the Claude Opus to find a database credential sitting in an unrelated file, and it decided to use it and delete the production volumes of a startup called Pocket OS. It took 9 seconds. And the agent never asked a human in the loop because there wasn't really one, so it just acted. So this isn't just a one-off. Few months earlier, an AI agent at Replete wiped a production database and then fabricated like fake users to cover its tracks. And if you look at Stanford's AI index, it says that they documented a 56% year-over-year jump in AI safety incidents. So the pattern is real and it's accelerating. So these aren't edge cases, they're what happens when autonomy outspaces monitoring. So a few years ago, using an LLM in production meant calling an API, getting a response, checking if it looked right. The LLM was a tool, you control the workflow, and every decision was a line of code you wrote. But that's changing fast. For your users, AI starts by helping, then earns the right to decide. For your engineering, you write fewer lines of code and more instruction files, and the AI picks its own step. And across the industry, agents start calling tools, evaluating other agents, and deciding what to do next. So the question that this raises is, when the LLM does more by itself, how do you know it's doing the right thing, and how do you keep knowing over time? So that's what this talk is about, and it sits at the intersection of the two concepts. So a little introduction. I'm Oscar. I'm from France originally, and I work at Clarity Care in San Francisco, where we build the AI for healthcare prior authorization. So we process medical records, we match them against clinical guidelines, and we help clinicians make decisions, basically. So there's lots of LLM calls in production, lots of stakes if we get them wrong. So what I'm going to share is grounded in what we've built for sure, and I'll also try to validate against what Anthropic and Airbnb, NVIDIA, and others have published in the last year. So there's two concepts to set up before we dive in. There's evaluating, which is understanding the performance. It's analytical, so is it working, and how is it failing and why? And monitoring, which is observing continuously, so it's operational. Is it still working? Did something change? These used to be separate concerns, and you'd evaluate before shipping, and you monitor in production. It would be two different teams and two different tools, but what's changing now is the relationship between them. What I've learned building production LLM system is that the industry is converging on some increasing of the autonomy, and these two things merge together. Evaluation becomes continuous and monitoring becomes intelligent. So they feed each other in a loop that gets tighter as the system does more on its own. So that's the framework. There are three parts. First, we'll go over evaluation, then monitoring, and finally what happens when the AI becomes more autonomous. So what are you evaluating? Let's start with what most people skip. Before you can evaluate, you need to understand what success means for your users. And what you evaluate changes as the system gains autonomy. So before you measure anything, before you even pick a metric or you build a test suite, you need to understand what success and failure actually mean for the people that are going to be using your system. And here's the thing, they often can't tell you. When AI is new to the industry, people don't know what's possible. They don't know what to ask for, and you have to try things to show them and learn from their reaction. So I'm going to share a concrete example from our work. We've built a complex pipeline for evaluating medical records against clinical guidelines. It was weeks or months of engineering. Meanwhile, we also built something much simpler, like clinical summaries, which is a couple of prompts that extract the key information from hundreds of pages of medical records. So not much, but it became the thing that users loved most. And the why is because it removed what they hate, which is reading dense medical documents, and it empowered what they're great at, which is the clinical expert judgment that they have. And this isn't unique to us. If you look at GitHub Copilot, if you've used it, they follow the same arc. They started with autocomplete, which became what developers fell in love with first. And only years later did Copilot become an autonomous agent. I'm also showing Harvey, which is a legal AI company that started as a contract review assistant in 2023 and only launched autonomous agents in 2025. And the last one is the contrary. They went the opposite direction. Klarna, they were all in on automation at first, and then they walked it back to a human hybrid model because trust hadn't been earned at the depth they thought. So there's a tension underneath, and this is something I want to name. The C-suite usually buys your product for automation, They want fewer staff, more throughput, lower cost per case. They're paying for the destination. But the people who actually use the product every day adopt it because it makes them better and faster at the job. They're using it for augmentation. You deliver augmentation first. You prove that the AI is reliable, and then you earn the right to automate. This shift has a name in the literature. It's called human in the loop towards human on the loop. The human goes from inside every decision to overseeing the system. Trust is the gating capability for that transition. And what you evaluate changes at every stage of that journey. So there's augmentation. Does the AI save the human time? Do they use it? You measure efficiency, you measure adoption. Then there's trust building. Is it reliable enough that human trust it? Now you measure accuracy, you build a failure taxonomy. And finally, there's automation. Is it safe to let the AI decide alone? And now you measure precision continuously and you monitor for regressions. So the progression is the thread of this whole talk. At each stage, what you evaluate changes, and the relationship between evaluation and monitoring changes too. So there's a trap here that I want to warn you about that we faced. We had like high precision on our like top metric on some things, and it sounded amazing, even for like selling our company, until you realize that the baseline approval rate was actually like very high as well. So our impressive number was barely above like approve everything. So not so impressive anymore. So that's the thing. There was a buried metric in there that actually mattered. Is when the AI says deny, how often is it right? And different stakeholders were like looking at different numbers and drawing opposite conclusions about whether the system worked. So your headline metric can sometimes hide the real problem. The whole industry is shifting from how smart is the model to does the system actually work for the people using it, you know? It's like your ground truth can also be noisy, by the way. A meaningful share of human decisions in our data had no explanation. So the human approved or denied, but didn't say why. So you're evaluating against an imperfect oracle in some way. So let's say that now you've defined what to evaluate. How do you systematically understand where your system fails? And we had a prompt rule, which has a guardrail that said something like this. It's a pseudocode, but if your reasoning contains some of these words, then the outcome should be no information found, which makes sense for clinical reviews. But the question is like, does the patient have diabetes? That is very clear, and it works. The guardrail will prevent the model from making up a no when it should say something like unclear. But if it's a different question, like confirm the patient has no history of organ transplant, then the LLM reads through the whole medical history. It reasons, it does a whole list, and it sees that there's no mention of any organ transplant. So the reasoning is correct. But then we have our guardrail, and it hits, and the absence, which was supposed to be the answer, becomes incorrect. The model knew the answer, but the guardrail like erased it. So this affected the majority of our negative criteria evaluation, which is a lot. And it was a single prompt rule, like a small thing, and it was designed as a safety measure, which was actually preventing correct answers on a massive scale for us. So the universal lesson here is that sometimes your own guardrails can fight your model's correct reasoning. The LLM might understand the nuance better than your rules do. And if you're seeing systematic errors, check whether your safety rules are causing them. This is the kind of bug you only catch by classifying failures and not counting them, which is the principle of this whole section here. If you look at an aggregate accuracy number, it doesn't help. Like we're at 90%, we want to get to 95. That doesn't say anything. What's the 10% that's wrong? Are they all wrong in the same way? We had, for example, 5 different failure modes. Each needed a very different fix. So when we investigated our production failure, we didn't just count cases the AI got wrong. We classified every disagreement between the AI and the human into specific patterns. And we found a lot, each one leading to completely different fixes. And that's the idea. They documented as well in Berkeley in some papers where they show that the structure of the taxonomy, well, vary of course by domain, but the methodology is universal. You have to classify and not count. So here's the shape. You pull your production data. For every case, you diff the AI decision against the human. Then you classify, and you classify what went wrong when you quantify each pattern, and you see which ones affected the most the production, which ones are cheapest, and so on and so forth. And that's the deliverable. That's what you want to get. It's not a score. It's a structured like understanding of how your system fails. And the methodology is also doing something else. The manual investigation you build, like the scripts, the queries, the classification logic, that's not like throwaway work. That's the seed of your monitoring system. And we'll come back to this a bit later when I'm going into this part. But also what's important is that things you try that don't work, that's also data. Like Claude Code last postmortem, or a recent one, was a public example of that. They automated benchmarks, and their automated benchmarks didn't catch some regression. So they had to build production monitoring and user feedback loops to find it. So what doesn't work also tells you what kind of safety net you actually see. Now, if we go into monitoring, evaluation gives you a snapshot, but your system changes and models get updated, data distributions shift, configurations evolve, even your customers can change. So you need to keep understanding continuously. So the first lesson is really the simple, and you just have to look at the math. A single AI call, which is Claude, the GPT, or whatever you want to do, it costs around, I think it's a penny. Maybe the values have changed since then. And if you log that call to an observability platform like BlockFire or something, it costs maybe, I think it's 2 millionth here of a dollar. So the ratio is roughly 5,000 to 1, which means that storage is much, much cheaper. Compare that to the cost of like engineering an engineer day spent debugging an issue with insufficient data, or some regression didn't catch, that the asymmetry is kind of massive. So the rule is simple. You log everything by default, and you manage retention smartly after. There's a real caveat at scale, because observability builds can outrun infrastructure. That's true. But the answer isn't to log less. It's to tier your retention. What to log matters as much as how much to log. So the idea is to track every LLM call with business context, like customer, case type, workflow stage, model version, prompt version, so that you can slice later if you want to show me all failures for this customer type with this model version or something. So the gap was between like we log everything and we can actually query it meaningfully is huge, and that's important. We had a real production case where one of our most important decision-driving signals, which was a little score, wasn't being persisted, and we only realized that weeks later. So we couldn't analyze it retroactively because we had never saved it. So what you don't log, you can analyze later. For monitoring, the loop is kind of the following. It starts with monitoring, then diagnose, then prescribe, then apply. And I'm going to go a bit later into each one of these. But it's 4 phases. They each builds on the previous, as you can see, and they create a loop that can continuously improve your system. And this isn't theoretical. It has a name, which I discovered when I was working on this talk. It's called the data flywheel, and it's used by Datadog, NVIDIA, LangChain, Arise, Anthropic. They all use the same term. Even some papers mention it, and the idea is always the same, like these four pillars. So I'm going to try to show a few examples. Here is an example from Airbnb. They published a paper in 2025. It's called Agent in the Loop, and they describe exactly the pattern that we just showed in their customer support system. And what they say is they saw a 12% improvement in retrieval recall, a 15% improvement in retrieval precision, an 8% improvement in generation helpfulness. So they also mentioned that retraining cycles were cut from months to weeks in what they did. So that's the flywheel effect. It's faster in iteration and compounding. I also have an example from NVIDIA that shipped this as a productized reference architecture called the data flywheel blueprint. They document here a tool calling case study where they replaced something like 70 billion of parameters for a model to become something that was only 1 billion parameter model. So the flywheel doesn't just improve accuracy, it can let you cheapen the model that you use without losing performance, because you've built up enough labeled production data to fine-tune a smaller model. So this works. So let me go back on this and actually try to walk through the 4 phases. I think that would help. Phase 1 is monitor. It's automated, it's scheduled. You compare AI decisions to human decision on a regular cadence. You track per category performance. You detect regressions when models or data or configuration change. So this is like evaluation in a way, but it's made continuous. Then you diagnose. When monitoring flags a problem, you classify the failure mode using the taxonomy from what we said in part 1. So same thing. And you see, is it an extraction miss? Is it a misinterpretation? Is it a wrong input? Something is going wrong. But the diagnosis tells you what kind of fix to propose. And then you go to prescription, which is based on the diagnosis. I propose a targeted fix. Here is where it gets, I think, interesting. When monitoring reveals that a certain category has been approved by humans, for example, 100% of the time over months of data, which we've had sometimes, the prescription might be, well, skip the AI entirely for that category, auto-approve, zero risk, direct product improvement, and it works. And this pattern has a name. It's called cascade routing, apparently. And people report that it's between 40 and 30% in 70%, in bill reduction by doing so. So it's just a fun side note, but I feel like we really got ourselves, and the literature also shows that you get improvement from this phase 3. Finally, you've got to apply at some point, otherwise it's all for nothing. So you push what you approved to prod, and you monitor again. So the loop starts again. Did the fix work? Did it break something else? And Anthropic, I think, frames their entire evolve like the philosophy this way. I think they even call it the Swiss cheese, because the idea is that they have automated evals like pre-launch, then production monitoring, then periodic human review, and multiple layers, each catching what the others miss, basically. So I've shown other companies' examples. I want to also show what we did. We run a manual investigation, which was a couple of days of scripting, querying production, databases, classifying cases. I know because I said we, but it was me, so I know how long it took me. And it produced the taxonomy that I was talking about, with the findings and the dozens of specific fixes that we could propose. So the point is that those scripts are the monitoring system seed. Like the manual work that I did becomes the automated system. You now schedule the scripts weekly, for example, and you add alerting when metrics regress, and you feed customer feedbacks in a ground truth. So today in our system, a human still runs the analysis and files the tickets, but we already have an agent that automatically watches our failure alerts in a Slack channel and automatically investigate these. And when a workflow fails, it queries our whole system. It reads application traces. It posts a root cause hypothesis, because of course it's never sure, but you have a link, you have suggested next steps. It's all in Slack for us, so we can read it within minutes. And that agent is doing the first 3 phases of the loop that we said. It monitors, it diagnoses, and it prescribes. So the human technically only has to apply. So it's like this loop is already becoming autonomous. And that's why I was saying, what happens when the AI does even more by itself? I've seen three forms of autonomy in what we do, and each one creates different monitoring needs. There's autonomy for your users, which is what I described in part one. It's augmentation to trust to automation. So in healthcare, clinicians started by using AI summaries to make faster decisions. Now, sometimes the system auto-approves routine cases entirely. It can be autonomy in your engineering. As you scale, writing custom code for each new capability doesn't work. So you shift to instruction-driven systems instead of code. So it's like more Markdown if you want and less Python. Shipping a new capability now becomes writing a document, not building a pipeline. And that means that more decisions are being made by the LLM, not by your code. So the monitoring surface kind of explode. And there's also autonomy in the industry when you see agents coding tools, agents evaluating agents. And there are numerous examples of this. For example, LangChain ran a survey at the end of last year. They had over 1,000 developers and business leaders. And I read through it, and two stats stick with me. They said that roughly 90% of organizations have implemented some form of agent observability. So this is not optional anymore. But quality remains the number one production barrier, which is about like a third of what the team cited. So the why is that I've seen this in two different recent papers as well. They describe the core challenge, which is agentic systems fail in ways that look like success. It's like incorrect but well-formed outputs. It's unnecessary tool calls, actions that are syntactically valid but semantically wrong. And your traditional pass-fail monitoring misses this entirely. This is why at the beginning I talked about Replete's database that was wiped. This is why the cursor agent deleted the production for Pocket OS. The agents weren't like crashing, but they were confidently doing the wrong thing. So when systems become more autonomous, what patterns keep them in check? So I found like three patterns that generalize. The first one is the referee. Then there's the judge, and then there's the investigator. I'll go through each one of them quickly. The referee is when sometimes you have multiple agents that are working on the same problem with different approaches or different information access. For example, we have one agent, one part of our system where like two agents, one has restricted access to the data and one has full access so that they see things differently. And both try to identify the right patient match. And then there's this third LLM that acts as a referee and receives both candidates with their reasoning and compares against criteria and picks the best. The key insight here is that the referee must know when to say, well, I can tell, I'm just trying here. And if the candidates are too close or the data is insufficient or these kind of things, then the referee escalates to a human explicitly with context for what to check. So it's part of its job. And that's, I think, the right human in the loop pattern. It's not like human reviews everything because that doesn't scale. And it's not AI decides everything because that's not safe from what we've seen. So the AI handles the clear cases and escalates ambiguous ones and tells the human exactly where to look. And that last part is very important. The second thing is the judge. So in one of our agentic workflows, we have a greater LLM that evaluates every step's output against ground truth. It's comparing what the AI step concluded against real human notes from the case, and it produces a 0 to 100 grade with reasoning. Critically, it's also cascade aware because when an upstream step fails, for example, like step 2 here would be very, very, very bad, then instead of punishing the next steps afterwards, it tries to grade fairly on the fact that the input becomes degraded for the next steps, like step 3 or step 4. And if the step admits it's missing data, then we go for automatic 0, so that we can distinguish between step failed its job from step did its best with bad input, And this is becoming standard practice from what I've seen, because Databricks ship an agent evaluation product. AWS Bedrock has a similar pattern. So the judge isn't like novel. What's novel is how cheap and how fast it's gotten to implement it. And here's something I do myself when I code and when I work. When I add a new capability to our pipeline, something I run test cases, of course, to verify. I have a judge LLM that grades the output, like we just showed. Then I have a second LLM that works the workflow CLI to analyze the trace, and the third that takes it both and summarizes it for me, and it's giving me feedbacks in minutes. Like 6 months ago, I think, maybe a few months ago, I would have run cases manually all the time, read traces myself, classified outputs by hand. Now instead of this full day of work, I'm becoming more and more lazy, that's for sure. But LLMs do most of the evaluation, and I review the reports. So I think that's the inner loop tightening. It's really that. And the last thing I talked about is the investigator. You need something that's watching the whole system, basically. So I was talking about our Slack agent. This is what it does. When a workflow fails, it automatically investigates, and it's autonomous. It queries out every history that it needs. It reads logs and traces. It checks the code base for recent changes. And within minutes, it posts a root cause hypothesis with a link and a suggested next step. But what makes this work, we give it guidance, not strict instructions. And I think that's kind of one of the key messages. The investigator agent that we have here has a skill document telling it where to find data, what queries to run, when to escalate. But it doesn't have like a step-by-step script anymore. LLMs are getting much better. It reasons about what to investigate based on what it's seeing. I think it's Anthropic that also articulates this exact principle. Yeah, I've checked a lot of Anthropic documentation, but they say that one failure mode is engineers hard coding complex brittle logic in their prompts to extract agentic behavior, which creates actually like fragility and increases maintenance. So the idea is the opposite. You instill good heuristics rather than rigid rules. OpenAI says the same, by the way. They want reasoning models that do better with high-level guidance instead of rigid prompts. So we try to follow this too. And the pattern is, it becomes at a point where agents evaluate each other at this. So that can be at any level. And the more autonomous your system, the more you need agents, monitoring agents, which you want them to be guided, not scripted. I think, at least that's my feeling. Which brings us to the last piece of this talk, and it's kind of a callback. So I described the loop earlier on: monitor, diagnose, prescribe, apply. For now, I said that the human runs it, like manual investigation, manual classification, manual fixed proposals. Now, apply the autonomy theme that we talked about. What if the AI runs that loop? Monitoring detects the failure pattern automatically, the same prompt rule causing errors across a category, which it's something we had. It classifies the failure using the taxonomy that you've made. It drafts specific fix. It's not like a vague improvement, but it's concrete amendment. And then it surfaces the proposal for human approval. So remember the guardrail rule that I talked about that like created a lot of failures in our system. Well, imagine, like, let's take a step back. The monitoring system detects that pattern automatically from production data. I don't have to do anything. It traces it to the specific rule, and it can propose the fix. You just have to review and you approve. It's like 2 days of investigation that I did myself a while ago that become now an automated alert with a ready-made solution. This is happening today in production, but the truth is the gap between research and deployment is still real. So I want to be honest about it. If you look at OpenAI's codebook, they document this as the self-evolving agents pattern. which is combining LLM as judge evaluations, failure synthesis, prompt refinement iteratively, and they report performance gain between 17 to 53%. Like the figure is not so important, but it's here. Another strong production example is DeepMind's Alpha Evolve, which is deployed across data center scheduling or hardware accelerator chip design, and even for Gemini's matrix multiplication kernel. So that's the proof point. It's in prod. But outside of this one, which is like the strongest example I found so far, I think that most like self-healing systems in production are still like vendor marketing, flavored. The PCs exist, but the gap between we built something in research and it actually runs in production is still wide for most companies. So let's not try to oversell where the industry is, but also let's pay attention because the PCs are converging more and more. So here's where I think it's all going to be. The human stays in the loop, but it's at a much higher level. It's approving changes, it's reviewing proposals, it's validating improvements. So autonomy doesn't mean unsupervised. It means that the system does the analysis and surfaces the recommendations, and the human makes the call. The more and more you become autonomous, I think the more and more you can have like your AI and your agents make smaller, easier calls that are well guided, and the human only focusing on the key part. But basically, that's here like it's really becoming one loop, and yeah, it's going to be tighter the more autonomy you can safely give. So to try to sum up, because I think we're running out of time soon. Evaluation used to be something you did before launch, and monitoring was something you would do after. It was like two separate concerns and two separate teams. And now that LLM systems become much more autonomous, and they will more and more for your users, for your engineering, and even across the industry, these two things merge into like kind of a single continuous loop. Evaluation becomes the methodology in a way that monitoring is going to use, and monitoring becomes the infra that the evaluation is going to run on. So the tighter the loop, the more autonomy you can safely give. 4 things to take away here. First, I'd say sell automation, true, but you deliver augmentation first. And evaluation is how you earn the right to increase autonomy. So you have to understand what users actually need before you decide what to measure. Then, when you evaluate, classify, and don't count, root cause taxonomy won't tell you where to invest. 90% accuracy was for us a vanity metric, and we actually saw a dozen failure patterns, which is actually a real roadmap. Then build the investigation first yourself, then automate it. Your own manual analysis is probably the monitoring system seed. Storage is cheap. Engineering days are not. Engineers are expensive. So log everything, or as much as you can in the right way. And finally, the more autonomous, the more these merge. The LLM with LLMs, the more they become the same thing, and the tighter the loop becomes. So notice the parallel that's run through this whole talk. Users went from doing the analysis themselves to reviewing the AI's recommendation. And engineers would go from investigating failures themselves to reviewing the AI's diagnosis. So that every level, the pattern is the same. Autonomy increases, humans shift from doing to reviewing, and the evaluation loop tightens. So yeah, that's the convergence. Thank you very much for listening. And yeah, if you have any questions, feel free to reach out.
Cool. Thank you, Oscar. To the audience, if you have any more questions, please feel free to add them. Here, let's see some of the questions that we've already gotten.
Yeah, I can start.
What metrics do you find most reliable for evaluating LLM outputs in production? Ragus, geval, something custom built. What's actually working for you?
Yeah, it's a very good question. I think so. you can use any kind of metrics you need for your own specific needs. I know it's a bit of a very vague question, but that's the reality. We tried very specific metrics. We try to be very statistical, very mathematical. I come from a very mathematical background, so I wanted things to be very tight in terms of metrics. And then I realized I actually have to make metrics and evaluation much closer to the day-to-day business needs. And sometimes it doesn't even feel like math or metrics anymore. It feels like reviewing documents manually. So I'd say it truly depends on what business you run and on what you're doing.
Yeah, makes sense. Next question. How are you collecting the ground truth data sets? And how are you deriving the eval metrics for this? Are you using any eval fixtures while scoring in prod, or just offline/CI based approaches?
Yeah, the first question, I really like it on how to collect the ground truth data set. It's a tough question because there's a kind of a vicious cycle here. You want to start a business or something, then you need to build your AI and your agents, whatever you want to build, which means you need a ground truth data set, which usually you would get by getting customers and having things being reviewed by them and then seeing what you need. So the reality is that at first, I think you've got to rely with what you can find in terms of data sets to start. And as much, the more and more you grow and you get customers along the way, the more you get feedback from them, and the more you should focus on the specific feedback that they provide to you. And I even think that, it depends on what business you run. Of course, we're more towards like B2B. So we try to collect for one customer a lot of data points. We even tried, once they start like really liking the product, to force them to give us feedback. You can never force them, but you try to add to your framework specific steps where if they want to change the outcome, for example, of a case or something, they have to give a reason why, so that we can know better and have actually that data set that we need to then run the framework, the monitoring plus evaluation framework, more concretely against real data. And there are other questions, I guess, in this. Sorry, I only answered to the first one.
How are you deriving the eval metrics? And are you using any eval fixtures that are scoring in prod, or just offline and CI based?
We don't have, we currently don't have real eval fixtures like in prod or day-to-day, but we do, as I said, like have some eval features that are run weekly, these kind of things. So it feels more CI based, I guess, because you're not like a daily every day or something, but we still have eval features, yeah.
Cool. Next question is, how do you balance security in a sandbox harness to reduce the surface area of an attack, and an autonomous agent finding a new service exists because of the first instance and now needs permissions?
How do you balance security? Yeah. Finding a new service exists because it's the first instance and now needed permissions. Well, that's a good one as well. I think, I'm not sure if I understand fully the question, but from what I understand, for autonomous agents, you always have to build things carefully, for sure, for safety. So the scope has to be small at first to measure if security is there. And the more you want things to become autonomous, like you can add things little by little and keep monitoring yourself, the safety of your agents. So that's still very human in the loop. But technically, there's no limit to that. And you could even imagine that some parts of your system have autonomous agents that are kind of monitored, even in terms of safety and security, by other agents if it becomes too big. I know it feels like it feels like a Ponzi scheme of agents that are monitoring themselves, but if well done, can work. At least that's my hope.
Cool. Thank you, Oscar. I think these are all the questions that people have. Are you going to be able to send us these slides? Can I send this out afterwards?
Yeah, sure. I'll send them to you. Yeah.
Great. So thank you very much, Oscar. Thank you everyone for tuning in today. You'll get the slides later. I'll clip this and we'll see a review for this, and I'll see you guys all next week. Thank you.
Thank you, everyone. Thank you for listening.